Welcome to this week's Contrarian Coding News. This week, July 26, 2025, in coding and programming, the most disruptive and unorthodox contrarian movements are emerging not just as new technologies, but as fundamental shifts in how we approach software creation, driven largely by the pervasive influence of AI. The post-coding paradigm and the rise of AI-native development. The most significant contrarian movement is a quiet rebellion against the very act of manual coding, driven by advancements in AI. While mainstream discussion focuses on AI as a tool for developers, e.g., GitHub Copilot for faster code generation, automated testing, and bug fixes, the disruptive idea gaining traction is that AI is fundamentally changing the nature of programming itself, moving towards a post-coding or AI-native development era. Argument: AI is rapidly automating repetitive and boilerplate coding tasks, reducing the need for junior-level developers, and shifting the focus from writing code to steering AI systems and ensuring quality output. Some experts predict that by 2025, generative AI models will manage increasingly complex front-end development, back-end API design, integration, and even data analysis. This challenges the traditional view of a programmer as primarily a code writer. Evidence: companies like GitHub are introducing extensions like Spark that enable anyone to create apps and websites by extending code, signifying a move towards more accessible, AI-driven development. Tools like Amazon's Kiro are emerging as agentic IDEs that excel at sustained development work by understanding business domain requirements and translating them into working code, even generating substantial portions of it, e.g., 80% of an 8,000-line pull request. This points to a future where developers are more AI supervisors and legacy system maintainers rather than primary code creators. The notion that AI won't replace programmers, but programmers who use AI will replace those who don't, highlights this shift. The contrarian insight here is that the definition of programmer is evolving to be someone who orchestrates and validates AI-generated solutions, rather than solely crafting them line by line. A radical idea is to build frameworks by AI and for AI, where UIs are defined by declarative JSON blueprints, making AI generation simpler, faster, and more reliable than traditional human-centric syntaxes like JSX. This implies a rejection of existing UI paradigms in favor of AI-optimized ones. 2. The re-emergence of unfashionable foundational principles and dark matter programming. In contrast to the AI-driven abstraction, a counterintuitive movement is the renewed emphasis on old-school or often forgotten foundational programming concepts, particularly in critical systems and performance-sensitive areas. This can be seen as a rebellion against the ever-increasing layers of abstraction that dominate modern development. Argument: while frameworks and AI tools simplify development, they can obscure the underlying mechanics, leading to a glass ceiling for senior developers and a lack of fundamental understanding among mid-level developers who learn to prompt rather than program. The contrarian view argues that a deep understanding of low-level concepts is becoming more critical, not less, as AI handles the superficial layers. Evidence: discussions among experienced engineers highlight the continued value of techniques like manual memory management, preprocessor macros, bit manipulation, and writing performance-critical code in pure C++. These are often overlooked in mainstream curriculum and modern high-level languages. The idea of hard failures, like asserts, versus soft warnings, runtime or testing toolchain reports on stack near overflows, performance monitoring, suggests a move towards embedding more rigorous, low-level operational awareness directly into development, rather than relying solely on abstract observability tools. The rise of languages like Rust, praised for preventing memory mistakes and being very fast for cloud and secure coding, underscores a movement towards systems-level thinking even in higher-level applications. This challenges the move fast and break things mentality often associated with agile and highly abstracted development. The concept of dark matter programming, where developers explore niche, highly specialized solutions for specific domains, e.g., a specialized PDE solver for climate or a meta-learning toolkit for genomic search, suggests a shift away from general-purpose one-size-fits-all AI models towards highly optimized, domain-focused AI architectures. 3. The rejection of one-size-fits-all methodologies and the rise of hybrid, adaptive approaches. While Agile, Scrum, and DevOps remain dominant, a subtle rebellion against their rigid application is emerging. The contrarian view is that a singular prescribed methodology is insufficient in the rapidly evolving AI-infused landscape. Argument: the traditional SDLC bottlenecks like manual workloads, inadequate resource allocation, and inefficient code reviews are being addressed by AI. However, the core issue isn't just automation, but the inherent unpredictability of software engineering and evolving user needs. Therefore, a truly adaptive, blended approach, tailored to specific project needs and constantly reevaluated, is more effective than strict adherence to any single methodology. Evidence: the acknowledgement that there's no one-size-fits-all winner in software development methodologies in 2025, and that organizations are blending different approaches to build their custom frameworks, indicates a move away from rigid adherence. Critiques of strict Scrum implementations, where the focus on sprint completion metrics can lead to technical debt and arbitrary deadlines, suggest a desire for more flexible, common-sense approaches. The concept of anticipatory culture in businesses, which involves identifying hard trends, future certainties, and pre-solving predictable problems, can be extended to programming methodologies. This means proactively adapting development strategies based on foresight rather than reacting to changes within a fixed framework. The emphasis on functional programming's principles like immutability and pure functions, which enhance reliability and concurrence for multi-core and distributed systems, can be seen as a move towards more predictable and maintainable code, even in traditionally imperative languages. This challenges the complexity often introduced by highly mutable state in large, rapidly changing projects. In essence, these disruptive movements highlight a fascinating tension. On the one hand, a push towards unprecedented abstraction and AI-driven automation. On the other, a regrounding in foundational principles and a rejection of rigid off-the-shelf solutions in favor of highly adaptive, context-aware approaches. This week, the most rebellious act in coding might be to embrace both extremes simultaneously, leveraging AI to its fullest while never losing sight of the fundamental mechanics beneath the surface. And that wraps up another edition of Contrarian Coding News, where the status quo is always up for debate.